Hi everyone, I am Kiran Chillarige from Dynamics 365 engineering team, and I will be walking you through the topmost anti-patterns that are impacting the performance on page loads for modern driven apps. I will also walk you through how can they be easily fixed with the recommendations shared by engineering team. I'll walk you through a dev instance with anti-patterns and the custom logic installed in that instance and their page load time. And finally, the improvement that could be observed in the same instance after applying the recommendations suggested by the engineering team. Let's get started. Microsoft Fast Track for Dynamics 365 is customer success service designed to help customers implement and go live so they can realize business value faster. Customers will gain valuable insights with solution implementation, onboarding, and continued education. Fast Track for Dynamics 365 represents our strong commitment to fostering the business success of our customers. When participating in the Fast Track program, customers will receive ongoing guidance on best practices and how to plan for successful rollouts. Fast Track program participants will receive emails with implementation guidance and communications about their active Fast Track engagement. In addition to proactive guidance and ongoing workshops, FastTrack customers will also learn ways to enable new users and expand capabilities, all at their own pace. This video helps you plan and optimize application performance with customer engagement apps. That includes Dynamics 365 sales, customer service, field service, marketing, project service automation, etc. One of the most predominantly used anti-pattern in customer instances is synchronous calls. These are blocking calls that delays the execution of the scenarios associated with them. These are triggered through custom logic which let the users perceive slowness while using these apps. This video helps in highlighting those anti-patterns that could be avoided while developing any new custom logic, and also helps in letting us know that fixing the synchronous calls is pretty straightforward and low risk. In this video, I'll walk you through a page load scenario associated with a custom logic that triggers synchronous calls. These are my two local dev instances. In one of the instances, all the anti-patterns related to the synchronous calls are triggered from custom logic, and in another instance, the fixes that was recommended by the engineering team has been incorporated. And this is the improvement in the form load times that you could see for the case entity, which is reduced from 10.8 seconds to 1.8 seconds. This is the blog that is published in Power Apps portal mentioning about the roles network request calls and how can they be easily replaced with XRM APIs. This is the code place where you are triggering a network request related to the roles for a particular role ID in a synchronous fashion. This can be fixed using an XRM API in the mentioned way. These changes are absolutely risk-free and you will not be seeing any new network requests related to roles post these changes. I would like to show a screenshot on the first example where the roles calls are triggered synchronously through custom logic and it is consuming almost 1+ seconds of execution time. Post fixing these roles calls with XRM API, there are no network requests that are getting triggered with respect to roles entity, and you get to see the amount of time that is saved is almost 1 second. In the same log, it is clearly mentioned on how asynchronous ribbon rule evaluation is supported in unified interface. Let's see an example. So synchronous requests are typically used in ribbon rules since the legacy web client only supported this strategy. This is a particular method where a synchronous call is getting triggered. This can be easily converted to asynchronous call by introducing a promise. Rest all the checks remain as is, free to interact with the page while the request is getting the data. User interface is no more freezing while the page is loading. The third way of triggering synchronous calls is from onload scripts through custom logic. These can be easily converted to asynchronous by introducing the promise in a similar fashion explained before, without any functionality loss. In my developer instance, I have introduced synchronous network requests on all three ways related to an incident entity. These synchronous calls get triggered from custom web resources. And I will walk you through how sequential execution of these calls take place in the Network tab of Chrome Developer Tools and how the same synchronous calls can be fixed and improve the page load times. This is my dev instance where I have associated the custom logic with case form load that triggers the synchronous calls related to roles and incident. I'll try to navigate to the grid view and try to open the case form. My developer tools for this browser is opened, and if you see, all these roles related calls are triggered in a synchronous fashion, each of which consuming more than 500 plus milliseconds, which is summing up to almost 4 plus seconds or 5 plus seconds of a page load time. I also have synchronous calls in my custom logic associated with incident. If you see here, all these calls are getting triggered in a synchronous fashion, each of which again is consuming around 500 plus milliseconds of time, summing up to around 4 plus seconds of page load time. The fast3g tag here in the network stats shows that we are in a good network condition. I'll show you how much of time it took to load the case form. In this green box, it shows in milliseconds, which is 12.6 seconds of time. I have another instance where I have fixed all the synchronous calls, either replacing the roles entity call with XRM APIs or converting the synchronous incident calls to asynchronous calls. Navigate away to the grid view, open the developer tools, fast3g, clear out the history, try to load the C1, I'll filter out for roles. You will not find any because these are replaced with XRM APIs. Try to figure out for incidents. These are getting triggered in an asynchronous fashion, not blocking the user. And the network condition is fast3g, which is a good condition. Now we'll see how much time it took. It took 2.2 seconds of time, which is a significant improvement from the other instance, which is 12.6 seconds. I would like to walk you through the custom logic that I have implemented in one of my instances that triggers the synchronous network request for incidents and roles entities. If you see, the initiator of this incident call is coming from new sync calls. This is my custom logic. Get incidents is the method which is registered for form load of incident. This method to be triggered. Within the get incidents, there is get incident name method that is being triggered. And within the get incident name, the request that is being triggered is specified as asynchronous by specifying false as a third parameter. The default value of this third parameter is true, which means that it is an asynchronous call. And this incident call is being triggered 8 number of times, which we were able to see in the Chrome Developer Tools network tab. Similarly, there is a get role sync call method that is registered to be triggered during the form load of case form. It is being triggered 4 times. Within that, the method get role name is being triggered. And in line number 11, if you see, the roles network request is triggered as a synchronous call by specifying the third parameter as false. I'll show you another instance where this custom logic is being fixed. In this instance, The initiative is new async calls. Get incident calls is the method that is getting triggered. The third parameter is not specified, which means that by default it is an asynchronous call. We have introduced a new promise. The rest of the logic stay intact. Similarly, for get role calls, we have replaced the network request with XRM APIs. There is also a new button that was introduced with custom logic during the rule evaluation, triggering roles network request in a synchronous fashion. That was fixed in this instance by replacing the roles entity network request with XRM APIs. With this, I would like to close this session by thanking you all for listening to the importance of avoiding the synchronous calls in custom logic and how it improves the performance of page load times by avoiding those. Thank you all.